The topic of this video is solving logarithmic and exponential equations. Let's look at a problem. Solve 6 to the 2x power plus 6 to the x plus 1 power minus 16 equals 0 for x. Okay, so we have seen a problem like this before, so this video will be a slightly abridged version when compared to that one. But we do have a similar goal. Everywhere there is an x in our equation, we want to write it in the form box 6 to the x raised to the box power, where each box contains a number and no x. Then temporarily replace 6 to the x with u. A little bit of clarification on the box here. It is possible for the number that you put in that box to be a 1, and since anything times 1 is itself, and anything raised to the first power is itself, then it would be as if there was no number there at all. What's really important, though, is that in these two positions, you have nothing at all or a number, but no x. All right, so let's go ahead and begin to solve this problem, and we'll see if we can achieve that goal. Okay, there are two terms that contain x. Let's start with the first one right here, which is this 6 to the 2x power. Okay, so this is where knowledge of rules from the previous math class are going to come in very, very handy. We recall that 6 to the 2x power is equivalent to 6 to the x power raised to the power 2. This is the power to a power rule that says when you have a base raised to an exponent, and then that whole thing is raised to an exponent, the two exponents get multiplied, and x times 2 is 2x. So these are equal. Notice that this is in the proper form. 1 times 6 to the x raised to the second power. And I do not have to write that 1. It is hidden, but we know that it's there. So we have 6 to the x, in parentheses, squared, plus. All right, the next the next exponent rule that we're going to use comes from here, 6 raised to the x plus 1. All right, so remember from our previous math class that this can be rewritten as 6 to the x times 6 to the 1. And the reason why is when you have two exponential expressions with the same base being multiplied, you add the exponents together. And of course, multiplication itself is commutative, so then this could also be written as 6 to the 1 times 6 to the x. Finally, 6 to the 1 is simply a 6, so we can get rid of that. And multiplication can be written with parentheses, so we can change that multiplication dot into parentheses. And now we have something more along the lines of what we're looking for. 6 times 6 to the x power. Notice that in this case we've got a number in front, and in this case we've got a number as the exponent, but both of them are the form that we're looking for. The rest of the equation remains unchanged. All right, this is the point where we use our u substitution. Everywhere in the problem where we have 6 raised to the x power, we're going to change that to the algebraic symbol u. This is just temporary, we'll put it back later. So when we do that, we now have the new equation. Instead of 6 to the x squared, it is u squared. Instead of 6 times 6 to the x, it's 6 times u, and the rest of the equation is unchanged. This is a simple quadratic equation. I say that it's simple because it has a leading coefficient of 1. To factor it, we just need to come up with two numbers that multiply to make negative 16, but add to make positive 6. Those numbers are negative 8 and positive 2. We'll put a u in front of each one and create two binomials. We can check this with FOIL. U squared matches here, plus 2u minus 8u would be minus 8u. That tells me that I have my signs backwards. Let's try again. U squared minus 2u plus 8u makes plus 6u, and then positive 8 times negative 2 makes negative 16. So now we know we factored this correctly. By the zero product property, 0 plus 8 is set equal to 0, 0 minus 2 is set equal to 0, and we get u equals negative 8, u equals positive 2. But remember, the instructions said to solve for x, so we are definitely not done with this problem. This is the moment where we now have to undo the substitution that we made earlier in the problem. So let's go ahead and do that. so we had u equals -8, u equals 2. But we also know that u is the same as 6 to the x power. So we're now going to put it back. The u will now go back to being a 6 to the x power. So instead of u equals -8, we'll have 6 to the x equals -8. And instead of u equals 2, we'll have 6 to the x equals 2. Okay, now both of these are exponential equations where the variable is up in the exponent. And we recall advice from a previous video that said, when what you are trying to solve for is up in the exponent, use your converter. So we notice that what we have is in the perfect form to go into our converter. We've got a base raised to an exponent equals an argument. We were not able to do this at the beginning of the problem because at the beginning of the problem, we had way too many pieces to fit into this tiny form. But now we are ready to use our converter. So let's go ahead and start with the first one, this one here. So the base is 6, the exponent is x, the argument is -8. Matching up the colors and shapes on the other side, we get log base 6 of -8 equals x. Notice that this has allowed us to solve for what x equals. Log base 6 of -8 equals x. We can do the same thing with the other equation. 6 to the x equals 2, so this -8 gets changed to a 2. Similarly, that means this -8 in the circle has to be changed to a 2. And we get the solution. Log base 6 of 2 equals x. All right, in a previous video we learned that the only kind of number you can take the logarithm of is a positive real number. So as we consider these two solutions, this one over here on the right is going to be okay because it does not violate that rule. We're taking the log of 2, 2 is a positive real number. However, this logarithm here on the left violates that rule because we're taking the logarithm of -8, which is a negative number. Therefore, this cannot be a solution. Now, we do still have to check this answer to verify that indeed it is a solution of our original equation, and we will do that in our next video.